Hello everyone, welcome back to Archangel RC. Yet another video of the ugly duckling will be filling up your spare time today, and in particular how it will handle its first autopilot system, the Detrum Z3 FPV one, and note I said it's first. Keep that in mind for later. At a first glance, the system does look appealing, offering plug-and-play functionality with pretty decent features and very, and I mean very, easy programming via a program card, so no complicated programming skills needed or a computer. GPS and power modules are included in the kit with all the proper wires and connectors, so no DIYing needed there, and it also has an OSD, which is mighty useful. All of that comes at a pretty decent price, to be honest, especially if it turns out that it actually functions as it should. It even has support for an airspeed sensor, though one is not provided with a set and there is no information which one is supported, though I reckon most analog options should work. The lengths of the cables of the components definitely would allow it to be used in larger planes as well, and actually things did end up a bit crammed in the airloader, but I wasn't about to start shortening those down, so the mess is proper. Since I was going to be using one new thing, I thought why not make it two new things, so I added the new AKK Race Ranger video transmitter to the mix, just so I can test it out and see how it will do. Have not played around with the new video transmitter in quite a while. Also got me one of those new long-range models with the fan on them, 3 watts of 5.8 GHz video. Should be an interesting test, but on another plane and later on. If you are curious about it though, you can check it out at the link below the video. Now, since I was adding a second new thing, thought why not make it 3 new things? And so the new Dragon Link 915 MHz radio system found its first use case. Yes, I have it and will be testing it, first on the airloader and later hopefully on something larger. Dragon Link do praise it pretty highly, so really eager to find out more in my own tests. A video about it will follow though, not going to be diving into it here. So let's get back on track with that Detrum Autopilot. One thing that I did not like from the get-go were the GPS and power module connectors, which can easily be plugged in reverse or in the wrong place if you're not careful or decide to forego reading the user manual. I've said it before and I'll say it again. Read the user manual a few times if you have to. Just make sure stuff goes in the right place and in the correct orientation. And the same goes for other things as well. Apparently there is a little arrow on one side of the connector. You should find it and note this is the ground wire. On the autopilot there is an indication which pins are ground and which signal, so it should be clear how this one should go in. Follow the same procedure for both the GPS and power modules. Now that this is done, it is time to connect the servos to the outputs. The wiring is pretty standard. Output 1 is ailerons, 2 is elevator, 3 is throttle and 4 is rudder. There is also a setup for flying wings and V-tail setup, but this is done via the program card. So again, read the manual. Next, you should connect your receiver either via S-bus or PPM to the correct port. Make sure you set the channels in your radio in the same order as already mentioned, but also add a 3-position switch to channel 5 for flight modes and a 2 or 3-position switch to channel 6 for the return to home mode. Believe it or not, this is it. Nothing else needs to be done for now, so you can go ahead and plug a battery into that power module to get things started and cross your fingers you got the connectors, direction and positions right. It is important that you do not move the plane during the initial power-up because it is calibrating its gyros during that time. Then read the manual as to how to calibrate level position. Basically, you place it on a level surface and flip the mode switch 6 times. The LED will blink green, indicating level calibration, and you should be done. Arming is done much like you would arm RGplane, throttle down and to the right for a few seconds, but unlike RGplane, this one does not require a GPS lock for that to work. At this time, you should flip the switch to the stabilized mode and verify that the autopilot is stabilizing in the correct directions. And just to be sure, look at it real careful and verify it a few times. Else, you run the risk of taking off with reversed ailerons, for instance, just like this example shows, and there is no telling where the plane would end up. Now, during this demonstration, it suffered no damage and it was planned that way. But who knows if you'd get so lucky, so make sure you check autopilot operation very carefully. If it turns out it is stabilizing in the wrong direction, you can adjust that with the program card, and only after you've made sure all channels are working properly from the autopilot, check if all channels are moving correctly from the radio and reverse any channels if needed. And since I mentioned the program card, might as well go over this briefly. Once the autopilot is powered on, only then connect the program card via the USB cable. You will also notice that the card itself can serve a few other purposes, which makes it a pretty versatile tool to have. So, once it powers on, you will see all the options you can adjust on the autopilot: channel reversing, stabilization gains, board orientation, etc. A host of things. Sadly, no options to adjust the OSD, but you can't have it all if things are boiled down to such simplicity. So, play around with the program card for a bit to familiarize yourselves with it, just for a good measure. Once all the adjustments are done and autopilot and radio are moving control surfaces in the correct orientation, it would now be time for flight and to see how this thing will be doing in the air. Keep in mind that if you have a video system on your plane of choice, you will have to run the video from the camera through the autopilot and then to the video transmitter in order to be able to see the OSD. Also keep in mind that the autopilot will power only the camera. For the video transmitter, you will have to figure out some other way of powering it, and since I am using a binary ESC on this one, it comes with an extra JST cable attached for just such an occasion. Since I also have the Telefly Pro module here for my antenna tracker, I added an LC filter to clean up the power supply before powering a back to step down voltage to 12 volts, and then the Telefly Pro, which in turn powers the video transmitter and its own GPS unit for the coordinates needed for the tracker to work. Not that complicated, and those without a tracker would have it easier, just need to figure out how to power the video transmitter. Might as well be directly from the battery, since modern day video transmitters are pretty well made and have good built-in filtering. So, now that all is done, tested and verified to work properly, it would be time to get this puppy in the air and see what it can do. One thing I'm happy about is the new all-up weight of the Airloader, which has seen pretty much no change from the previous one when I flew it with the larger battery and the DJI Osmo Action camera. Only now I am using the smaller battery because of all the extra gear in it, but the weight has not changed, so I can expect the same performance as before as far as that is concerned. I did make sure to balance it in the same way as well, pretty much neutral, and again, make sure you check all control surfaces for proper operation and direction of operation both from the radio and in stabilized mode before you take off. Come takeoff, I was just reminded again that the Airloader is a pretty nice plane to fly. Throttle up to 70%, manual mode, give it a nice toss and away it goes. No issues, no drama. However, post takeoff is where the drama actually started. Thought I'd try the gyro mode first and did notice the plane would roll to the right more than in manual mode, all trims being reset after the autopilot install. I did try calibrating gyros and levels a few more times, but this kept on happening, so upon asking DynamRC, the people making this autopilot, I was informed that this is normal and I should just trim it out. Problem with this suggestion is that it needs so much trim that when I switch to manual later on, it starts rolling to the other side, and same with stabilized as well, because trim has the same effect as holding the stick in that direction, so it affects all modes. But I said, okay, so I'm not going to use the gyro mode, it is kinda useless for an FPV long range plane anyway. I reset the trim to where the plane flew well in manual mode and switched to the stabilized mode to see what that was about and hopefully start getting some height and distance to check the long-range capability of the plane and the race ranger video transmitter. However, the Detrum Z3 had other plans, and so this is how things with the stabilized mode went. I released the sticks and the plane would, at random, pitch up or down, all on its own. After a turn, it would keep the roll for a while after that. Kinda reminds me of iNav in that regard, not to mention that the OSD seemed particularly familiar, so who knows. In any case, it was not a stable, stabilized mode. Even after resetting all trims, it kept doing the same thing, and it was an effort to keep it level actually, which was a new experience for me. With these results on hand, I was not willing to test out the return to home at this point, not to mention that when I sat down behind the monitor, I was greeted with this information on the OSD screen for altitude and distance from home, and both were completely wrong. And I wasn't even sure how this is even possible, not to mention that there was no home arrow, which is a huge drawback of any system. So, basically it turns out that stabilized mode doesn't really stabilize, and upon asking Dynam they said it's because PIDs were too high and I should lower them, so I guess that program card will see some more use after all. I haven't done that yet, but we'll try it soon to verify, but I doubt that would fix the crazy altitude and distance from home numbers, which you can see on the OSD even before takeoff, and they keep changing even though the plane is stationary. So it turns out, in addition to not being able to rely on a level plane, you also would have no idea how far you are from home point, how high you are, or in which direction home even is. So assuming those GPS coordinates are correct somehow, you are going to have to start checking them mid-flight to get an idea where the plane actually is, especially when flying in an unfamiliar area. But even with all of this, I decided to keep the plane close, in an area I know, and to try and take it up to the clouds, which were pretty low this day, a miracle around here to be honest. The idea was that I know the area well enough, and I can always switch to manual mode and bring the plane home. After all, I'm not going more than 2 kilometers out. Also, I have the antenna tracker with its own working GPS unit which tracks the plane, so I have a pretty good indication of where it is, roughly, as it is pointing to it at all times. So, I go around in circles gaining altitude, not that the OSD showed anything useful as far as that goes. And all of a sudden, just as I'm about to break over the clouds, Autopilot limits my throttle and the plane starts wobbling like crazy and dropping the nose down a good deal. So I thought perhaps I had the throttle too low, and so I try again. I keep an eye on the voltage, on the amps, assuming amps are correct, voltage was indeed correct, and go up again. And same thing happens. As it is going up, throttle is high, all looks good, and all of a sudden all goes to hell, and you can't really tell what exactly is happening because the current meter has a delay in the reading. You drop the throttle and it doesn't immediately become zero, but it takes some time to wind down to zero, which was ridiculous, and in addition the speed was super inconsistent, which might indicate some issue with the GPS unit or the algorithm of the autopilot responsible for that. So, being stubborn, I did try a few more times with the same results every time, and I really was bummed out because it was not often that we have such low clouds and I could have gotten some nice shots above them with the DJI camera. But on the other hand, I was laughing a lot because the whole situation was ridiculous. Plane was like a fly bumping its head against a glass window, not being able to pass through, or in this case, go higher. But anyway, turned back and started thinking about whether the autopilot has some sort of battery failsafe where it wouldn't allow it to go below 14 volts, because this is where the battery was at the time, or if there was some height limit it was adhering to. I did ask Dynam about it and their explanation made no sense whatsoever, so I still have no idea what happened, but I will be back there to try again. Only issue with the height limit theory is how does it know how high it is when it was showing a minus altitude all the way up? This has been the most perplexing flight I've ever had, with the most insane OSD readings ever. But if you even for a second thought this is where the fun ended, you'd be very mistaken. As I came down and started circling above the field, I thought I'd see if that flat spin is still achievable. I know a few people asked never to repeat that with the camera on it, but just bear with me for a bit. So I followed the known procedure: throttle off, full up elevator and full right rudder, and I kept holding them like that for a while, and the plane did go into a flat spin, but since I was high, it took a while to get down. At some point I let go of the sticks and tried to take it out of the spin, but with no luck. After trying a few more times and not even hearing the motor spin, and keep in mind all of this is happening within a few seconds, I look at the monitor and I see on the OSD that it says disarmed. There was no time to be annoyed or shocked even. I did the arming sequence, it did arm, during the flat spin no less, but by that time it was already too low to be able to take it out of the spin, so it touched down in leaf orientation and not at a very high speed. As I was walking towards the plane, I was contemplating the absurdity of it disarming in flight during a spin, because after that I tried disarming it stationary on the ground and it wouldn't disarm using the same stick sequence, so what allowed it to disarm in the middle of a flat spin is so far beyond me that I wasn't even going to be thinking about it anymore. As you can probably guess, the guy over at Dynam didn't even understand what I was asking about, and there was no reply to this question as well, but something like this should be impossible. I urge you to try and disarm an Arduplane controller in flight using stick commands. It is just not happening. And I'd hate to be the guy praising the Airloader again, but I have no choice in the matter. This unusual landing did reveal something interesting. The flat spin ability is actually a safety feature. Any other way of landing it potentially could cause a lot of damage, whereas this way of doing it via flat spin only cracked the nose a bit along the glue joint between the two fuselage halves, which is super easy to fix even with some tape, and there was no other damage whatsoever on plane, foam or electronics, not even a wrinkle or a crack on the foam at all. Absolutely brilliant performance out of this ugly duckling. So remember, you get in trouble with the Airloader, get it into a flat spin, has the best chance of survival. As for the Detrum Z3 FPV Autopilot, given everything up to this point, I hardly think there is need for me to sum it up again. It is just bad. It is very bad, even if dialing down the PIDs fixes up the stabilized mode, which I doubt. Everything else that is wrong with it will still persist. I only hope that either I got a faulty unit or this can be fixed via a firmware update, which I urge DynamRC to do sooner rather than later. The price point certainly is good, but not if it costs you a plane with several $100s worth of gear on it. Remember my comment about the Airloader's first autopilot at the start of the video? Well, if this is not resolved soon, it will most certainly be getting a second one. I would probably test it a few more times and do another video of my progress with the Z3, but until then, links for all items shown and used can be found in the description below, and buying literally anything through them would support this channel at no additional cost to you, and you will have my eternal gratitude as this is my full-time job. Another way you can support me is Patreon, the link is also there, and I would like to say a big thank you to all the people who have supported me so far in any way and would continue to do so. If you have enjoyed this video and found it useful, please feel free to like, share and subscribe if you haven't already, and don't forget to hit that bell button so you can be notified when I upload a new one. Also consider following me on Facebook. Happy and safe flat spinning, hopefully on purpose, and I will see you in the next one.